In this lesson, our last lesson, we're going to talk about how we can describe the shape of data, of numerical data. So if you look at your workbook page 351, we're going to talk about a couple new words, some you may have heard before. A set of data can be described by its shape. A cluster is a group of data values. So when you have data values that are kind of grouped together, they're clustered together. A peak is the value that appears most often. So think about, a peak in a mountain is how high it is, or the top of it. So a peak is a value that appears most often. When you see it on a dot plot, you're going to see it go to the very top, having the most dots. And a gap is an interval with no data. So a gap is just, numbers that don't have any data there, this empty space. And an outlier, we talked about an outlier before. An outlier is an extreme or a distant value. It looks like it doesn't even quite belong with the rest of the data. So for number one, if you look at this dot plot here, we're going to describe the shape of the data, and we're going to use words like clusters and peaks and gaps and outliers. So let's see, let's start with the clusters. If you see right here, we've got a cluster from 2 to 4. And then we have a cluster again from 7 to 12. These are clusters because you see you have a bunch of data values that are kind of grouped together, that are clustered together. So, clusters of data appear from 2 to 4 and 7 to 12. So there we have some clusters. Now let's talk about gaps. So gaps are where there's no data. So I'm going to do a different color here. Let's do red. So we have some gaps right here, but around the 5 and the 6. And then we have gaps again from the 13 to the 18. So those are where we have gaps. That means there's no data values, in that range of numbers. So gaps in data appear from 5 to 6 and 13 to 18. Okay? And now let's look for peaks. Peaks are where the data shows up most often. So you're going to see data values that have the most in our dot plot. So if I go with, let's do a different color again. Let's go with blue. So it looks like our peak is right here at the 2 because the 2 shows up the most. And so you can see the dots in our dot plot are the tallest above the number 2. So the peak is, I'm going to run out of space here, is at 2. And then the last thing we're going to talk about is outliers. Let me just erase this. So an outlier is a number that's really far away from the rest of the data. It's kind of distant. It looks like it doesn't quite belong with the rest. So in this case, it looks like our outlier is this 19 over here, because that 19 looks a little bit further away than our 2 to 12 area. So let's see, the value at 19 is an outlier. Okay, so that's what all of those words mean. That's what you would see when you're looking for clusters and peaks and gaps and outliers. Okay, now let's look at numbers 2 and 3. We're going to talk about what happens if we kind of adjust our data a little bit. We've talked about this before. The median of the data we know is 8. So if you were to cross off all those numbers and work your way to the middle, you would get 8. Would the median change if it was calculated a second time, but without including the value at 19? Remember, 19 was the outlier that was kind of far to the right. Explain why or why not. Well, if you're taking that extreme away, if you're taking away that 19, then the median, the middle of the data, may shift a little bit. It probably would shift a little left. So let's see, the median would shift left or decrease because there would be one fewer data value greater than the median. So if we take out that number to the right, it's going to shift our data, our median values, to the left. And now let's talk about what happens if we do some changing with the mean. The mean of the data we know is 7. So if we were to add up all those data values and divide, we were going to get an average of 7. With the mean change, if it was calculated a second time, but without including the value at 19, explain why or why not. So again, what if we took out that outlier? What if we took out that 19? Would the mean change? Yes, the mean would also move left or decrease in value because the sum of the values would decrease. So if you were to add up all of those numbers before you divide, when you add that 19 in, that makes a big number that you're adding in. And now to take out that 19, you know, the sum, when you add up all those numbers, is now going to be less. So when you go to divide, you're going to end up with a smaller mean. Okay, and now number 4, which measure, mean or median, best describes the set of data? Give a reason to support your answer. Well, if you remember, the median was 8, and I'm going to just draw a line here. So let's see. This was our median. Our median was 8, and our mean was 7. So which measure, mean or median, best describes the set of data? Give a reason to support your answer. I'm thinking the median might be a little bit better. It looks like it's closer to the rest of the data. So the median would be better because 8 is closer to most of the data. And it's interesting that our mean is 7 because we have this outlier at 19 over here. And that outlier of 19, because it's so big, you would think that it would make the mean a little bit bigger than it really needs to be. Because typically when you have an outlier, you want to usually go with the median and not the mean. Because it could make the number a little bit smaller or a little bit larger than the average should be. But it does work out here that the median would probably still be better, even though our mean is lower, because most of our numbers are closer to that 8. We have, we have some 2s and some 3s and some 4s, but then we also have these 9s, 10s, 11s, 12s. So I think 8 would probably be the best measure of central tendency to describe this data. Alright, so here are the takeaways. So we've got some new vocabulary. We have cluster, gap, peak, and outlier, the definitions, and we have some examples over here. And then at the bottom, just a reminder, with measures of central tendency like mean and median, typically it's best to use the mean when there is no outlier and best to use the median when there is an outlier.